Hello, I am Dr. Megha Bhambre, working as Assistant Professor in KVNI College, Nashik. Now we will see the topic subspace. A non-empty subset W of a vector space V is said to be a subspace of V if W itself is a vector space with respect to vector addition and scalar multiplication defined on V. Now we see the theorem. A non-empty subset W of a vector space V is a subspace of V if and only if W satisfy the following conditions. That is, W satisfy C1 and C2, where C1 U plus V belongs to W for all UV belongs to W, and C2 KU belongs to W for any scalar K and for U belongs to W. Now, here, if W is a subspace of a vector space V, then by definition of vector space, W itself is a vector space with respect to vector addition and scalar multiplication defined on V. Means W satisfy C1 and C2. Conversely, suppose W is a non-empty subset of a vector space V, then W satisfies C1 and C2. Means W satisfy closure axioms and addition axioms A1, A2 are inherited from V. Similarly, multiplication axioms M1, M2, M3 and M4 are also inherited from V. But from C2, for any scalar K and vector U belongs to W, Ku also belongs to W. Now, for A3, if we take 0 belongs to R, that is a real number, U being a vector belongs to W, then 0 into U is equal to 0, which also belongs to W. For A4, if we take K is equal to -1, which belongs to R, and U be any vector in W, then -1 into U is equal to minus of U. It is an vector which also belongs to W. And hence A3 and A4 are satisfied. And therefore, all conditions of vector space are satisfied by W. Hence, we can say that W is a vector space. Now we will see the theorem. A non-empty subset W of a vector space V is a subspace of V if and only if alpha W1 plus beta W2 belongs to W for all alpha beta belongs to F and W1 W2 belongs to W. We know that for any vector space V, 0 bar and V itself are subspaces of V. Now we see the example. Determine which of the following are subspaces of a given vector space V. If not, justify. First one, W is the set of elements xy belongs to R square, satisfying the condition 5x plus 3y is equal to 0. Second one, W is the set of elements xy belongs to R square, satisfying the condition 2x plus y is equal to 3. W is a set of elements xyz belongs to R cube, such that y plus z is equal to 0. Now, we will see the solution. Consider set W is the set of elements xy belongs to R square, satisfying the condition 5x plus 3y is equal to 0. Let U and V are the elements of R square, and hence we can write U is equal to x1 y1 and V is equal to x2 y2. But U and V are elements of W, therefore we can write 5x1 plus 3y1 is equal to 0 and 5x2 plus 3y2 is equal to 0. If we add these two vectors, that is U plus V, then we get x1 plus x2 plus y1 plus y2. Consider 5 into x1 plus x2 plus 3 into y1 plus y2. Then we get 5x1 plus 3y1 plus 5x2 plus 3y2. But in above, we can see 5x1 plus 3y1 is equal to 0 and 5x2 plus 3y2 is equal to 0, and hence their sum is also 0. Means u plus v satisfy the condition of w, and hence u plus v belongs to w. Now we see second property. Let k belongs to R be a scalar, then ku is equal to k into x1 comma y1 is equal to kx1 comma ky1. Consider 5 into kx1 plus 3 into ky1 is equal to k into 5x1 plus 3y1. But 5x1 plus 3y1 is equal to 0, and hence k into 0 is equal to 0. Therefore, we can say that ku also belongs to w. And therefore, w is a subspace of V, which is equal to R square. Now second one example, that is W is the set of elements xy belongs to R square such that 2x plus y is equal to 3. Let us consider u is equal to 1 1, which belongs to W, and k is equal to 2, then ku is equal to 2 2. Therefore, 2 into 2 plus 2 is equal to 6, and which is not equal to 3. Therefore, it does not satisfy the condition of W, and therefore W is not a subspace of V. Now we will see the third example. W is a set of elements xyz belongs to R cube, satisfying the condition either x is equal to 0 or y is equal to 0. For this, we consider two elements u and v such that u is equal to 0 1 3 and v is equal to 4 0 2, satisfying either x is equal to 0 or y is equal to 0. If we add these two elements u and v, then we get u plus v is equal to 4 1 5. But this element u plus v does not satisfy condition either x coordinate is equal to 0 or y coordinate is equal to 0, and hence u plus v does not belongs to w. Therefore, w is not a subspace of V, which is equal to R cube.